Let's now turn our attention to one big idea that comes out of chapter 23, and it's all about the meaning of this word significant. So a lot of times when you read articles in the news, they might say that the findings were significant or the findings are statistically significant. We want you to understand what it means if researchers say the results are statistically significant. And we also want you to understand how that differs from being practically significant. So these terms actually came up for us close to the beginning of the semester. I think maybe in chapter 5 or 6 they came up for the first time. And now we're getting some more details about this. So what does it mean if something is significant within a statistical context? Well, it really depends. So significant can mean a couple of different things. If we say the findings are statistically significant, it means that chance alone is an unlikely explanation for the findings. And another way of thinking about that is that if you obtain a small p-value, it means your findings are unlikely to occur just by chance alone if the null hypothesis is true, and you'll reject that null hypothesis. So when researchers say the results are statistically significant, it means they've rejected the null hypothesis. They've obtained a small p-value. If we say the results are practically significant, it means that they have important implications. And just because the results are statistically significant does not automatically mean that they have important implications and that they're practically significant. In a moment, we'll talk about why this is. But we always want to be thinking about the implications of the results. Are people going to make important decisions based on these results? Are they going to change the way they operate or change the way they do things based on the decisions? Or based on the conclusion? So are they going to change the way they do things based on the conclusion of the test? Or are any results that we obtained really just trivial, minor differences? Judging statistical significance is very objective. You compare your p-value to your alpha level. You make a decision then about rejecting the null or not rejecting the null. Judging practical significance is more subjective. So to really be able to think about the practical significance of findings, you really need a good understanding of the field of study under question and research that's already been done in the field. So we don't all have that, obviously. So it's a little bit harder to gauge practical significance. We just want you to again have this understanding of what it means when we say the results are or are not practically significant and what would influence that. So again, statistical significance versus practical importance. As I've already mentioned, a finding can be statistically significant without being practically important or without being practically significant. It's actually really easy to get statistical significance. It's really easy to obtain a small p-value. If you increase your sample size, that's going to help you obtain a smaller p-value. And again, obtaining a smaller p-value is going to make it easier to reject the null hypothesis. That doesn't necessarily mean that something important is going on because we've rejected the null. We just got a finding that would be unlikely to occur if the null is true. Conversely, you can have a situation where you have a very small sample size, and because the sample size is too small, you're not able to reject the null hypothesis. You're not able to get a small p-value. But there could be something important going on. There could be a large difference between your sample statistic and the claimed population parameter, and you're just not able to reject the null because, again, you just haven't sampled enough people. With a larger sample size, you would have a better chance of rejecting the null. So we always want to be looking at multiple things here. We want to look at what is the actual difference between that sample statistic and the claimed population parameter. Is it small and trivial? Is it larger and would it be important? How is the sample size factoring in? Is it large and is that leading us to get a small p-value, or is it small and is that why maybe we're not able to reject the null when we think we should be rejecting the null? So there are lots of things to be paying attention to here. And I know I'm saying this now in the abstract and just kind of throwing a lot of definitions at you, but let's look at an example where it might make a little bit more sense. So in this particular example, we're dealing here with SAT preparation. So some of you maybe took the SAT, maybe you took a course to help you prepare for taking the SAT. Let's say that there's someone named Dr. Math who has put together a course, and he wants everyone to take his course. He said that if you take his course, you're going to do better on the math portion of the SAT, better than average. But his course is kind of on the expensive side. It's $900. And you might not have that money. Your parents might not want to spend that money on this. But he claims that if you take the course, you're going to do significantly better on the math portion of the SAT than if you don't take the course. So let's say in the population, students score an average of 513 on the math SAT. 1 year, Dr. Math offers his course. He has 50 students in the course. They take the course, and then they go on to take the math SAT. And they score an average of 515 with a standard deviation of 90. So obviously they're doing a little bit better on average than the national average, but does this convince you that you should pay $900 for this course? Is 2 points higher on average enough to maybe get you into that first choice of college? So we might ask you, is this evidence that students are scoring significantly higher than 513? So hopefully you're thinking now that to answer that question, you'd have to conduct a hypothesis test. Is 515 significantly greater than 513? Well, to be able to answer that, we need to end up obtaining a p-value, and that'll help us determine if we should reject or not reject the null. But I want you to just kind of be paying attention here to the fact that there's really not that big of a difference here between 515 and 513. Maybe not big enough to justify spending this much money on this course. Now let's think of a second scenario. Again, we have Dr. Math, basically the same setup here. This time, however, word has gotten out about his course. Everybody wants to take it. He has 10,000 students now, rather than 50. And these 10,000 students, they go on to take the SAT. Again, they get an average of 515, and again, they have the same standard deviation as before, a standard deviation of 90. Is this now evidence that students are scoring significantly higher than 513? Would this convince you to spend $900 on this course? So to answer this, we'd have to conduct a hypothesis test. I encourage you just for practice to go through the steps of conducting the hypothesis test. The only thing that's differing in these two different scenarios is that first we start with the relatively small sample size of 50, and then we have a pretty large sample size of 10,000. Here is what things would look like if we computed a test statistic in each case. So notice here that oops. No. I just need to find my notes so I write down the right thing. Okay. So notice here that when we have 50 individuals, we get a test statistic of 0.2. So 515 is over here. Here's what our p-value would be. And again, we're looking at the upper tail because we want to see, do students do significantly better than 513? So our alternative hypothesis would be mu is greater than 513. The null would be, the null would be mu equals 513. And actually, if you carry this through and end up finding a p-value, it ends up being 0.4207. Over here, again, everything is the same. The only thing that's differing is our sample size. But having a much larger sample size here leads to a different sampling distribution. Here you'll see in both cases they're centered at 513, but here we have a lot less variability because we're going to have a really tiny number down here in our denominator. So here 515 is out here. And the p-value in this case, so let me make it clear that we're talking about p-values here. is going to be 0.0139. And again, our hypotheses would be the same. So simply increasing the sample size, look at what it does to the test statistic. It leads to a bigger test statistic. It leads to a result that's further out in the tail compared to over here. And it leads to a much smaller p-value. But that difference up here remains the same, and it's a pretty small difference. So statistically, we have significance here, but I would argue that the results may not be practically significant because of the fact that there's really not that big of a difference here. If you score a couple points better on the math SAT, is that going to help you get into a different college, maybe get into the college of your dreams? It's certainly possible. I'm not enough of an expert in that to know, but it seems like it's unlikely that that tiny difference would change decisions that are made or would make that big of an impact, would be practical. So those are things we want you to think about when you're thinking about the difference between statistical significance and practical significance. With statistical significance, we just look at the p-value and whether we're rejecting the null. But with practical significance, we really have to think carefully about the implications of the findings. So what I'm going to do next, let me see where we are. Let's kind of maybe end this with a question here. More on interpreting p-values. If you conduct a hypothesis test and obtain a p-value of 0.01, how would you interpret this? Or what is the meaning of a p-value of 0.01? So think about how you'd answer this. Right away, I'm hoping that you're excluding a few things here. There's a 1% chance the null hypothesis is true. So a p-value is not telling us the percentage, or is not telling us how likely it is the null would be true or not. We're assuming it's true to start off with. So that number is not telling us what percentage of the time it would be true or whether there's a certain percentage of a chance that it's true. There's a 1% chance you would obtain your sample statistic or a more extreme sample statistic if the null is true. That sounds pretty good. That could be the answer, but let's read the other ones before we commit to that. Only 1% of the population was included in the sample, so that's not what the p-value is telling us. There's a 1% chance your sample actually belongs to the population you thought you were sampling from. Hopefully you're excluding that. We've never talked about that before, so hopefully that does not make any sense. B is the best answer. Remember, the p-value is telling us something about the probability of our sample results under that assumption that the null hypothesis is true. We're always starting with the assumption it's true, and we want to know how likely it is we're going to get our sample results if we start with that assumption. Okay, so let that sink in a little bit. We'll come back, we'll talk more about this, and again, we'll do more practice. I'll try to wrap everything up in one more video. I can't make any promises, but I know you're wondering, when will this ever end? Well, pretty soon. So hang in there with me.